Okay, so today we're going to be going over our last gas law, and this is going to be our last gas law. If you guys can write the name down. It's called Dalton's law of partial pressures. Okay, and you guys don't need to write down that long paragraph there. You can just write down the equation. It's super duper simple. I'll go over what it means in a second, but take a minute to write down the name of the gas law and the formula. Okay. Okay, so what this gas law basically tells us is, let's say, for example, we have two different gases. Okay, so let's say we have oxygen and this is the pressure. Say we got nitrogen and this is the pressure. If you put them in the same container, okay, the total pressure, so the P tot, the total, is going to equal just the sum of the pressure of the oxygen and the pressure of the nitrogen. That's it. Okay, so if you want to find the total pressure of the system, you just need to add up the pressures of the individual gases that make it up. Okay? Super duper simple. Okay. All right, so let's do a little pop quiz just to go over, see if you guys understand this topic. It's super easy. So let's say, for example, that we have two different gases, okay? So let's say, hold up, let me cover this up real quick. Okay, so let's say that we have a container, okay? And inside the container, we got, let's say, we got water vapor. Okay, so I'm gonna draw some water vapor. So let's say this is our water vapor. Okay, the pressure of the water vapor is 10 atm. Okay, and then let's say that another gas that we have in there is hydrogen sulfide, and let's say that the pressure of the sulfide is 5 atm. Okay, what's the total pressure in there? Yeah, 15. That's it. That's how you use this gas law. Easy peasy. Lemon squeezy. Okay. All right, let's make it a little bit harder. Let's say that the total pressure inside of the system is 20. Okay. And then let's say the pressure of the sulfide is 5. What's the pressure of the water vapor? What's the pressure of the water vapor if it's, yeah, 15. That's it. Okay, that's how you use partial pressure law. Make sense? Okay. All right, so let's go over a problem. It's not going to be that easy. I would never do that to you guys. I respect you way too much to make it that easy. Okay. All right, so we got this problem right here, and it tells us that we have a mixture of oxygen gas and methane. Okay, so I'm going to draw a quick picture just to kind of help you guys visualize. Okay, so inside this container, we got 6 grams of oxygen gas. So 6 grams of oxygen gas. And we have 9 grams of methane. Okay. Okay. It tells us that the container, the volume is 15 liters. And the temperature is 0 degrees Celsius. Okay. Everybody good on where we got that info? So just to go over it, we got 6 grams of oxygen gas in there. Okay, yeah, so inside the container, we got 6 grams of oxygen gas. And inside the container, we also got 9 grams of methane. It tells us the size of the container is 15 liters. And the temperature is 0 degrees Celsius. Okay, everybody go with that? Make sense? Okay. So the question is asking us, what is the partial pressure of each gas and what is the total pressure? Okay, so I know this is a little bit different from any of the problems we've seen before, but it's super easy. We're basically going to be using the ideal gas law and then the pressure law we just learned. Okay, so I'll show you guys how to do one of the steps, and then you guys can finish up the problem, okay? So it's telling us to find the partial pressure of each gas, which means that we are looking for the pressure of oxygen and we're looking for the pressure of methane. Okay, so we need to find both pressures. Okay, now, unfortunately, we cannot do this at the same time. We have to do them individually. Okay, so the first step we're going to take is let's find the partial pressure of oxygen. Okay, now, if you guys notice, we have grams, we have volume, and we have temperature, which means we can use the ideal gas law that we learned last time, PV equals nRT, to find the pressure of each gas. Okay. Okay, so let's start by figuring out the pressure of the oxygen. Okay, so pressure of oxygen. So let's plug in our numbers. So since we're looking for pressure of oxygen, we're going to leave that alone. Okay, what is the volume of the oxygen? Yeah, it's 15 liters. It's just going to be the size of the container. Remember, gases spread out, so it doesn't matter how many gases are in there. Okay, the volume is going to be the size of the container. So for example, your fart has a lot of different types of gases in there. You got methane, you got some water vapor, you got some hydrogen sulfide. That's the thing that makes it smell bad. But they still expand together, right, in order to fill up the room. And so the volume of a gas, no matter how many there are in there, is always going to be the size of the container. Okay. All right. Do we have the moles of the gas, of oxygen gas? You guys see moles of oxygen in here? No, but can we find the moles of oxygen? Yeah, super easy. We just need to take the 6 grams of O2. Okay. And then we're going to divide it by the molar mass of oxygen. And I'll do the calculation for you. It's 32 grams in 1 mole. And if you solve this part, that's where you get your N. Okay, so I'll let you guys solve that in a second. The R value is always the same. It's 0.0821. And then for the temperature, you just need to add 273.15 to get the temperature. So it'll be 273.15. Okay, so I'm going to give you guys about a minute or two to work with the person next to you. See if you guys can figure out the moles of oxygen using the molar mass, and then solve for the pressure of O2. Okay, so I'll give you guys about 2 minutes to do that. If you finish early and you feel confident moving on to the next step is pretty much the same thing. This time, instead, you're going to be finding the pressure of methane instead. Okay. So I'll give you guys a couple minutes to work on that, and then we'll go over it together. Okay, guys. So we're going to find the molar mass, or we're going to find the moles of oxygen using the molar mass. Again, we got this 32 by going to the periodic table and adding up the molar mass of oxygen twice, because that's what O2 is made out of. So we're just going to do 6 divided by 32. And so what we get for the moles is we're going to get 0.18. I'm going to round it up to 8 moles of O2. Okay, and this is going to be our value for N. Okay, so inside this equation, probably should have written more space, but it's going to be 0.188 for our moles. Okay. All right, so we got to solve for the pressure of oxygen. So in order to do that, we got to divide both sides by 15. So we're going to divide by 15. That way we can make the pressure of oxygen by itself. Okay. All right, I'll stop right there before we finish the calculation. But any questions how we got this set up? Okay, hopefully not too bad. It's pretty much what we did last time with the ideal gas law. Okay, so we're just gonna do the top, multiply the top. So 0.188 times 0.0821 times 273.15. And then we're gonna divide that by 15. So the pressure of the oxygen is going to be 0.28 ATM. Okay, so what we did first is we turned the oxygen, the grams, into moles. And then we just plugged it into the ideal gas law in order to find the pressure of oxygen. All right. Okay, so I'm going to pause right there. I'll give you guys about 3 to 4 minutes. see if you guys can do the same thing, but this time with CH4. I want you guys to find the pressure of CH4. Again, you want to find the molar mass. You're going to turn the grams into moles and then plug it into this equation. So I'll give you guys about 4 minutes to do that, and then we'll go over it together. For this problem, for this part of the problem, we need to just do the same thing, but this time we're going to start with the numbers for CH4. So let's start with the molar mass of CH4. So we're going to take 9 grams of CH4 and we're going to turn it into moles. So we got to find the molar mass of CH4. Okay. This should not be too bad. You're just going to go to the periodic table and then we're going to look for C and H. Okay, so H is 1 each. How many H's are there in CH4? 4. Okay, so that's going to be 4. And then carbon is 12. So we're going to do 4 plus 12, which is 16. Yes, 16. So the molar mass of CH4 is 16 grams in 1 mole. All right, so math for this should be pretty easy. We're just going to do 9 divided by 16. So we're going to do 9 divided by 16. And that's going to give us that value. So let's round it to 0.56. And that's going to be moles of CH4. Okay, from there, super easy to plug it into our equation. Okay, we're looking for the pressure of CH4. The volume is 15 still. The moles is right here. We just calculated 0.56. The R value is 0.0821. And the temperature is 273.15. Okay. Same thing as before. To find pressure, we just divide both sides by 15. Okay, and you just need to plug it into your calculator and we're all done. Okay. So for the math, it's going to be 0.56 times 0.0821 times 273.15 divided by 15. And that's our final answer. Okay, so the pressure of the CH4 is 0.8. I'm going to round that up to 4 atm. All right, so that's the pressure of the oxygen. That's the pressure of the CH4. All right, and then for the last step, in order to find the total pressure, okay, we just need to add the pressure of the oxygen and the pressure of the CH4. Okay, so you just need to add the two numbers together. So 0.28 plus 0.84, and we get a total pressure of 1.12 atm. Okay, and that's what the majority of the questions on your assignment is going to look like. So the total pressure is pressure of oxygen, which we got right here, 0.28. Plus the pressure of CH4, 0.84, and we add them together and we get 1.12. So that's the total pressure. Yes, most of them. Alrighty, guys. You guys ready to move on to the last question? Okay, so the last question is gonna look a little bit different, and it's gonna be very similar to the questions that we do in AP Chem. So just to kind of give you guys a little taste of what some of the questions might look like conceptually, I wanted to include this into today's lecture and your assignments. Your assignment will have problems that look like this, okay? So I know it looks kind of funky, but I'm going to explain what's happening, and then from there, the math actually isn't too bad, okay? So the thing in AP Chem is that a lot of the questions, the hardest part is just kind of figuring what in the world's going on. So let me just explain what's going on, and then from there, you should be able to tell the math isn't too bad, okay? All right, so basically you have this little contraption right here. On one side, we have N2. So on this side, we have N2. And then on the other side, we have O2. Okay, does that make sense? And then do you guys see this little valve right here, right? Okay, the valve is preventing them from mixing. Okay, so before the gases are mixed, it's telling you that the N2, the size it takes up is 2 liters. the pressure is 1 atm, and the temperature is 25 degrees Celsius. Does that make sense? Yes? Okay. The other side of the container, the size is 3 liters and the pressure is 2 atm. Okay? So that's how the gases start. Okay, and then the question tells us the valve is opened, so the gas is allowed to mix. So the two gases mix together, okay, because we opened the valve. So the nitrogen is going to basically spread out. It's going to go to this side and mix with the oxygen, and the oxygen is going to go to the other side and mix with the nitrogen, okay? All right. So let's do the first problem. So the gases are allowed to mix. Okay, so it's asking us about nitrogen. So how did the volume taken up by nitrogen change? Okay, so let's look at this contraption again. So how much volume did nitrogen start with? What was the volume of nitrogen in the beginning? 2. It's right here, 2 liters. Okay, so it starts at 2. Okay, but if it opens and the nitrogen is allowed to spread out, what's the new volume? Not 3. Yeah, 5, because it starts at 2, right? This is nitrogen. And then it's allowed to spread out, and it spreads out all the way here too. This other side is 3 liters. So the new volume, so let's write new volume of the nitrogen is going to be 5 liters. That's it. That's part A. Okay, the gases mix, it spreads out, and so it'll take up the space of the entire container, which is 2 plus 3. All right, so far so good? Okay, let's move on to part B. So the part B is asking us, what is the partial pressure? So the pressure of nitrogen after mixing. Okay, so if we take a look at part B, what's the variable that we're looking for? Are we looking for P, V, N, T? What are we looking for? P. We're looking for P. Okay. All right, so we're looking for P, and we're comparing it to the old pressure of nitrogen. The old pressure of nitrogen was 1 atm, right? Now, if you guys remember the old gas laws we talked about, if something changes, right, it goes from P1 to P2. So that means the P1, the old pressure, was this right here, 1 atm. And so if the pressure changed, this is going to be P2. You guys remember that from last week? Okay. So we're looking for how the pressure changes. Now, if you take a look at these 3 variables, okay, we got volume, we got pressure, and we got temperature. So the question is already telling us the pressure changes. What else is going to change? Is the volume going to change or the temperature going to change for nitrogen? If it's spread out, what changed? Volume, yeah. And we already saw that in part A, right? The old volume, P1 or V1, was 2 liters. And the new volume, V2, is 5 liters. Okay, so again, just to reiterate, we solved in part A that the volume changed from 2 liters to 5, right? Because the nitrogen spread out. That means the pressure also changes. Okay, so if you guys remember, we got P and V. This is going to be so this problem is going to be an example of Boyle's law. So we're going to be using P1 V1 equals P2 V2 in order to solve part B. Okay. So I'll give you guys about 2 minutes. See if you guys can plug this into your calculators and figure out what the new pressure, the P2, is using the numbers that we have right here. Okay. So take about 2 minutes to do that. Okay, so if you guys notice, P1 is 1. So we're going to plug in 1. Okay, V1 is 2. Okay, we're looking for P2, and V2 is 5. Okay, so all we got to do is move the 5 to the other side, and we do that by dividing by 5 on both sides. So P2 is just going to be 1 times 2 divided by 5. Okay, so the math should be pretty easy. Okay, it's just 2 divided by 5. And so P2 is going to be 0.4 ATM. Okay, and this is going to be the partial pressure of N2. Okay. Any questions on how we got that? Okay. All right, so I'm gonna go through part C really quickly with you guys, and then I'll show you guys how to finish it up. Okay, so part C is pretty much the same thing, but this time we're gonna be looking for O2. Okay. All right, so we're looking for the partial pressure of O2, so we're still looking for P2. Okay, so we got to figure out the P1, the V1, and the V2 for oxygen. Okay, so let's take a look at this side right here to look at oxygen. Okay, what's the P1 of oxygen? 2. Yeah, the original pressure is 2. Okay, what's the original volume of oxygen? 3 liters. Okay, we're looking for P2. Okay, what's the new volume of oxygen after it's allowed to mix? Yeah, 5. Same thing. Okay, and then from there, it's really easy to solve this, right? Same thing, it's just Boyle's law. We're going to do P1 V1 equals P2 V2. So we're going to do 2 times 3 V1 equals P2. And then V2 is 5. Okay. All right, and then in order to solve for P2, we just move 5 to the other side by dividing. Okay, so for the math, all we have to do is multiply the top. 2 times 3 is 6 divided by 5. And so we'll get a pressure of 1.2 ATM for oxygen. Okay. So that's going to be our answer for part C. All right, and then last but not least, in order to find the total pressure, we already know how to do that, right? Total pressure, we just need to add these two numbers up. And so the total pressure is going to be 1.6 ATM. That's it. Okay, so you will have 2 problems on your assignment that do look like that. So I'll leave this up here on the screen for you guys. And obviously you guys have it in your notes as a reference, but it'll be very similar to this. Okay.